Hello and welcome to the Oxford MAT Livestream 2024. It's great to have you with us. How's everyone doing? Fantastic to see people here live, and hello also to people who are watching the recording. For people who don't know, these are on YouTube live on Thursday afternoons, but they're recorded and they stay up for a while. So if you're watching the recording, we recorded this live on the 6th of June 2024. It's MAT time, yeah. And I'm not going to send you the answers. Who says that in chat? Right, hang on, let's put chat on screen. I've got to get used to this. I've got to get used to this. I've got slightly different controls to my other live stream, so I've just got a little bit used to that. Shout out to Callie, who is moderating chat for me today. Hi to people in chat. Here we go. There was a request there to increase the character limit. I think I know how to do that, but not while I'm live. So future weeks might change that around as well. Hi to Ozzy and Imo and Matthew at the top there, Maya and A, and some anonymous people. If you would like to join live chat, you can do that over at slido.com/MATLIVE, Mat Live, which is where you can join in with chat. I'm going to have it on screen some of the time, and I'm going to switch it off some of the time to make space for more maths. Enjoy that while it lasts. I'm going to switch that off in a moment to tell you about the map. Oh, here comes another bunch of people. Syrup's joined the chat as well. There's Callie in chat. We'll sort Callie whizzing past. There goes Callie. Callie moderating chat. Callie's a current student who will make sure that people are nice to each other in chat. Normally when we've done this, people are very, very nice to each other in chat. But that's where we go. The rules for the live stream are, of course, please do not swear and do not divide by 0. Those are the two main things that we try to avoid on the stream. Do you have a chance to be the top in you? Oh, you do have to be the. Oh, okay, it's an admissions question. Yeah, so people can ask admissions questions in here. I will do my best to multitask and occasionally take questions from chat. If at any point you ask a question and you think that I haven't seen it, then you don't have to spam it lots of times. Maybe I have seen it and just don't have time to answer it, which doesn't mean it's a bad question. There's an email address where you can send us any questions you like, any time of the day or night. We won't reply immediately any time of the day or night, but you can send us them whenever you like. That email address is undergraduate.admissions@maths.ox.ac.uk. I've said it really quickly. There's a link in the YouTube description, and if you search a little bit, it's not hard to find us for the contact. Buenas tardes. People watching Spain. Brilliant. Yeah, let us know where you're watching from. Great stuff. Okay. Oh, this is nice, isn't it? Here we go. I'm going to switch off chat on the screen. It's still running. I can still see it. Say hi. Let us know what's going on. Oh, I said all of that about questions. Let's take one question there. Do you have to be the top in your year to have a chance at Oxford Maths? I think no. And I suppose the more relevant thing is that Oxford won't know if you're the top in your year, whatever that means. I suppose your teachers or reference might say something that compares you to other students, but that's not really something we have data on for whether you're the top in your year. And anyway, maybe the person who's the top in your year doesn't want to do maths at Oxford or maths at all. Who knows? We're looking for people who are good at solving maths problems who are going to do well on our course. It could be 2 at the same school. It's not impossible. Right. Okay, right, before we delve too much into comparing yourself and imposter syndrome and thinking too much about kind of mental side of things, I want to tell you about the test. This live stream is all about this one particular test. I guess you have probably heard of it if you've clicked on this on YouTube, but I do want to tell you about it. So let's do this. I want to start by telling you a little bit about maths, and in particular, the maths admissions test for 2024. So first things first, it's MAT, which I say MAT rather than MAT because it's quicker. It's the maths admissions test. It's used for maths, computer science and joint honours at Oxford, and we use it at Oxford to help us shortlist. It's not the only thing we look at, and we have access to lots of information from your UCAS form, other facts about applicants, but the MAT gives us a chance to see how you solve maths problems. So it's an important part of people's applications. Am I up to date with the chat? I've had Buenas tardes from Spain at the top for quite a while, but probably that's fine. That was what people needed to say. Good, right, okay. Facts about math. Let's go. So, I've been excited to tell people this for ages, and this week is the first time I can tell people about this. You ready? Let's go. Here are some facts about MAT 2024. It's a 2.5 hour exam. That's the same that it's been in recent years. If you get extra time in other exams, then you should also get extra time in MAT. There'll be a way that you can request extra time for access requirements or special needs. There are no changes to the syllabus. The syllabus is the maths content that we expect people to know at the time they take the MAT. And it's that syllabus, that list of maths topics that we're going to go through for the MAT live stream. We're going to do some revision material on those topics, and we're going to do some math problems based on those topics only, because that's the maths that is used for the maths admissions test. It's going to be taken in Pearson VUE test centres as a test that you do on a computer, for which you will be able to register free of charge between the 15th of August and 4th of October 2024. The date is somewhere between, the date has not been confirmed. So in chat, people are speculating about the date, but the date is not confirmed at the time of this recording. It will be late 2024. And as soon as it's confirmed, I will let the MAT live stream know, of course. We'll update the MAT page too, but I would let you know. Yeah, so there's already a good question in chat. Let's just quickly show chat show question. So it says, online, how are they going to make sure it doesn't crash like in other years? The crucial thing that we have changed is that last year it wasn't with Pearson. Last year it was with some different people. And things did not go well. It was also taken in schools using whatever equipment or computers that people had. This year I'm really looking forward to working with Pearson, who have this established network of test centres, lots of experience about doing online tests, and lots of capacity for people taking the test at the same time. I think that's what I'm going to say. So I think I want to draw a line under things that happened in 2023, and I think the university has very clearly by switching to new arrangements with Pearson establishing this. My says dates come out and it's in November, and again I will tell you when the date is confirmed, and I just want to observe that there are two anonymous people who think there are different rumours about when the test is. I'm really sorry that we don't have precise dates. So it's going to be taken in VUE test centres as an online test. You are going to have access to, in the test centre, some way of doing rough work, because you'll need somewhere to do rough work. We're going to publish lots more details and some video of what happens in the test centre, that kind of information as we get closer to the test. We're going to go and hopefully film some stuff so that you can see what it's like in a test centre as we get closer to the test. But it's only just this week been announced by the university that we're working with Pearson. I've been excited to tell people about this for quite a while, and now I'm allowed to. Okay, here's some format details. The format is very similar to previous years, which is why we're going to be looking at past MAT questions as part of the MAT live stream. We're going to be looking at past multiple choice questions and past long questions. The MATs always had these mix of multiple choice questions and longer questions. The number of each of those is changing this year just a little bit. For one thing, there are going to be 25 multiple choice questions. Those are going to be in the same style as multiple choice questions from previous MAT papers, which is why we're going to be looking at those for the live stream. And there are going to be 2 long questions for which you're going to type responses. And to get ahead of the obvious questions about that, you're not going to be expected to type complex mathematical expressions. You're not going to be expected to do LaTeX expressions or typesetting, or you're not going to be expected to use any sort of equation editor or symbol entering or any weird stuff. You're going to have a standard keyboard, and the people writing the questions know that. So the questions are going to be written so that you don't have to write complex mathematical expressions as part of your answer. Instead, you should expect to justify your answers or explain your reasoning. I'm really looking forward to seeing what people do for these 2 questions, where instead of just selecting an option, you're going to explain your reasoning a little bit. So that's what's going to be happening there. Okay. So Matt is correct. Matt is not going to be in schools. It's going to be in Pearson test centres, and we've gone online. And partly that's a security thing, and partly that's a delivery administration thing. Okay, right. So hopefully this is reassuring. We're doing the same sort of thing that we always do, which is multiple choice questions and a couple of longer questions where you show your reasoning and you explain your answer. There will be a practice test to show you what that mix of multiple choice and long questions look like. There will be a practice test on the website at some point soon. We're putting together a practice test to give you an experience of what that looks like. Okay. How do I think? Oh, loads of good questions in chat. So you're not going to show your work for multiple choice questions. And for the longer questions, I think you'll find that you'll be able to type your response in the boxes. Okay, right. Okay, marking quickly. The multiple choice questions are going to be worth either 2 or 3 or 4 marks, and that will be indicated throughout the test for each multiple choice question, whether it's a 2-marker, a 3-marker, or a 4-marker. Multiple choice questions are marked just for the right answers. You'll select the right answer, and you'll get the marks for selecting the right answer. And the long questions are worth 15 marks. Your answers can be marked by humans for the long questions, and partial answers get partial credit, which is what we've been doing for the long questions for as long as there have been long questions. So are the multiple choice questions, question in chat, are the multiple choice questions like the MAT ones in previous years? Yes, which is why we're going to look at some of them. The idea is exactly the same. We want to show you tricky maths problems that you can work your way through, but multiple choice is a useful thing for us in this test for recording your answers. There's a request for more than one practice test, so I want to lower expectations a little bit. The practice test is made of past questions. Because the style of the questions isn't changing, and because the syllabus isn't changing, we've put together past questions to act as the practice test. So once you've seen one, you should get an idea of what the format looks like. Okay, good. So fully computer-based. This is a computer-based test. You do it online in a Pearson test centre. So you will do the test in a test centre. Okay, which is a change from previous years. Okay, so higher scores on longer questions. Hang on, hello. Are higher scores on longer questions rewarded better because you spent more time and effort in it, or the 15 marks weighted the same? So a mark is a mark. These are 15-mark questions. The multiple choice questions are worth fewer than 15 marks. Tutors will have access to your marks for the different questions. So tutors at Oxford can see the breakdown as well. Okay. And the question there, are the long questions the same as past years? The idea is that we're trying to do something similar with those long questions to give you a chance to not just tick an option, but also explain your working out. Okay. Right, good. Okay, I'm going to let the questions roll a little bit while I put up one more thing. No, it's facts about the live stream now. Okay. That's a question about why some of them are worth 2 and 3 and 4, and partly it's so that the total adds up to 100. So the format is 25 multiple choice questions, 2 longer questions. And everyone does the same questions in MAT 2024. There's no specific computer science or philosophy question. In fact, there's never been a specific philosophy question. What am I saying? But there's no computer science section in 2024. Okay. So the college you're marking, well, that's a good question. Does the college you're applying for mark the test? No, there's a kind of coordinated effort. I lead a team of markers, and we get the scripts for absolutely everyone. We don't even know, at that point they're anonymized, so we don't even know who's applied to which college. The markers are graduate students who might be at a particular college, or they might be at a college that doesn't have any undergraduate students. So there's no kind of pairing up like that. Good. Okay. Quick look at chat. Total amount of marks in the paper is still 100. I think a good score is still going to be what I usually say, which is I still think the average mark is going to be about the same, and I think 70 will be a pretty good score. That's the intention. Yeah, so people, it's at least one person in the chat wants to talk about the crash last year. So last year when it crashed, Oxford Mathematics stepped up and organised a replacement activity for students affected by a crash. Yeah, okay. Results go directly to Oxford, so that Oxford can make shortlisting decisions. You don't need to do anything. So results go directly to Oxford, and then in January, all Oxford applicants get all Oxford applicants for any course get a automatic email with their score, with one or two exceptions for other courses. But okay, if I stick to MAT, then yeah, MAT candidates get sent their score automatically in January, which saves you from asking it, which is quite a while, I suppose. But it's already gone to Oxford, and Oxford already then maybe invited you to interview, and maybe you moved on and we made an offer. Okay. Good. Right. Okay. Fewer marks for long answer questions compared to multiple choice. Yes. Yes. So there are 2 long answer questions. Okay. Instead of in previous years, the balance has been a little bit different. Okay. Good. Right. Facts about MAT Livestream. So that's the map. And aside from all the kind of tech details that were on the previous couple of slides, aside from all the tech details, the idea is still the same. That we've written some maths questions for maths applicants to do. We would like to see how people cope with unfamiliar maths questions, especially ones where they have to understand something and then tell us about it. Okay, there will be stuff about polynomials. I promise I'm getting to the maths. Yes, I know the video is called Polynomials, and there's some polynomials coming. I'm very excited to get to the mathematics. Thank you for waiting through. One person is waiting through maths information for maths information. We will get there. Okay, quick overview of what this is, just so that we're clear about what we're doing. We've got a series of worksheets with revision notes, revision questions, and past math questions with hints. That's so that we can build up from A-level or equivalent, so whatever you're studying at the moment. I hope you get to see some content on polynomials, and how that bridges towards math questions, because math questions tend to be a bit harder or more unfamiliar than A-level questions. We're going to do a live stream each Thursday from 5 o'clock to 7 o'clock UK time. Fans of the Maths Club, that's right, I'm staying live for an extra hour. So from June to October, I'm taking a summer break in August. More details will be posted on the Matt Livestream page. Not about my holiday, just more details about the live stream sessions. We've got one worksheet up already for this week, and the ambition is to get all of the rest of the worksheets up very, very soon. Okay, we're live on YouTube. Anything could happen, except dividing by 0. And the streams are going to be recorded to watch back later. Okay, you can watch back at double speed if you like, which I've been told by my current students that watching back at double speed is what they liked to do. So maybe it's worth saying at this point as well that last time I checked, about 50% of current Oxford students engaged with Matt Livestream at some point while they were applying. So maybe that means that I'm talking to half of my students in a future year. Half of my students are currently watching the anyway. Okay, this is me peering into the webcam. Actually, solutions and extensions are posted on the Matt Livestream page as well. That little website there is the Matt Livestream page. I'm also going to read it out: www.maths.ox.ac.uk/r/matlive. That's the Matt Live page where we're going to try and post loads of stuff. That link is also in the YouTube description, and hopefully if you search for Matt Livestream, I've been doing this for a few years, I hope I'm near the top of Google now. Maths with an S, because we're British. Sorry. Oxford Online Maths Club is on a break now. This is the 5 o'clock slot. I can't do both at the same time. So Oxford Online Maths Club is on a break. We'll be back at some point in the future. Okay. Oh, that's a good question. It's got loads of thumbs up straight away. Let's have a look at that. If you get a good score in the math, how much will your predicted grades matter? Yeah, so your predicted A in further maths. So in the normal offers, we're looking for A star in mathsy stuff. Yeah, okay. So tutors are going to look at this sort of information in totality. Tutors are going to look at predicted grades, maybe your previous academic qualifications, if you've got some of those, and they can look at your MAT score, read your personal statement, reference, all of that stuff. What I'll say is that we know that predicted grades are not always correct. So on the one hand, the MAT is an actual test where once you've done it, it's a thing you've actually done, whereas your predicted grade is more of a kind of guess about the future, and we know that they're wrong surprisingly often. So in some sense, the MAT is really useful to us because it's concrete information. If you're asking about predicted grades because you know that you're about to get your predicted grades because you're in year 12 or something, then I would encourage you not to worry too much. Your teachers, for example, your teachers don't have to base their predicted grades solely on some sort of mock exam. They don't have to do that. They're allowed to predict grades based on any information they have. I'm going for a kind of soul read where I try and guess who you are and why you're asking the question as well. Good. Can I tell you what the highest mark achieved last year was? No, I don't think I can. Sorry. I should know that sort of stat. What score do you need for a MAT for an interview? We've got no hard cutoff, but I always say the higher the better. Right, okay. Quick advice about how to use the MAT Livestream. I'm jumping backwards and forwards, talking to chat, reading the screen as well. The suggestion is that you look at the revision notes first. They cover the MAT syllabus stuff. Probably you've already seen this material, especially for polynomials. We'll have a look at it together in a second. You could have a look at the revision questions if you're not sure whether you've seen it before. The reason we started this in the first place is that the syllabus gives you a list of topics, and we were getting questions about what those topics actually involve. So sometimes to be clear about what topics we mean. And then you might like to try some MAT questions, but without looking at the solutions. And then there's a big gap, because you really shouldn't look at the solutions yet. But then later you can look at the solutions. We put them on the website as well. You can join the live session at kind of any point through there. During a normal live session, after this first one, where, goodness me, I've been talking for 20 minutes without doing any maths. Normal session, I'm just going to jump in with some maths. You can join in if you've got questions, if you want more detail, or if you just want to see some of the questions done live. I'm going to try and do some of the maths live on the internet. Anything could happen, except swearing or dividing by zero. If you want any of that, then the live streams are here as a resource. I'm quite enjoying the live chat in here. Yeah, you see, for example, people ask nice questions like, Callie, what college is Callie at? So Callie can chat to people in chat. That's nice. And what do I teach? I teach applied mathematics, and in first year I teach a lot of the calculus, which is good fun. Teaching students to integrate and partially differentiate. Good. Has anyone got 100%? And if so, can they take the test for me? Says someone in chat, which fun times. Yeah, okay, so I'm going to say A-level a lot as well. There's a question in chat about A-level equivalents. I'm going to say A-level quite a lot, but lots of other qualifications in the world are equivalent to A-level, and they teach very similar material. Part of the reason I'm doing this is because if I just say A-level, that doesn't mean anything at all to a lot of people. But if I show you some polynomial facts, then maybe you've already seen them. Let's do that now. Seems like a good thing to do. Ooh, I didn't know it would do that. Oh, that's nice. There you go. Let's transition to tell you about their syllabus. So I've got the MAT syllabus there at the top, which is just a list of polynomial facts. That's what I'd like to talk about. I think I'm going to talk about this for about 15-20 minutes, and then try and jump into some questions. So we're going to try and do that. The transition would have been better if I didn't have this blue rectangle at the bottom. I'm just going to try and deal with that. Oh, there we go. So that was almost slick. It kind of cycled round into my whiteboard. There we go. Okay, so we're going to learn about the quadratic formula. Woo! Here we go. We got a little bit of screen tear on that, haven't we? That is not perfect. That'll probably get better with time. Techie animations. Wobbly writing. I think my handwriting needs to improve. Right, okay. Let's close that, that's gone now. Okay. Quadratic formula, but also completing the square, which I think different people refer to completing the square as different things in different places. So I've got an example of what that means. Maybe you've got a different name for it. If so, let me know in chat. We're going to learn about the discriminant, factorization, and the factor theorem. And if you see me looking that way, it's because I've got a copy of that top bit over there. We've got stuff going on. Let's go. Okay, so here's some notes on what completing the square means. I've got this little calculation here, which it's a way of writing quadratic expressions. And to check that this is true, which I guess you should do when somebody presents a statement like that to you, is to multiply it out, I suppose, to prove this. If you wanted to check that it's true, mathematicians love checking that things are true. I'm going to copy this out. B squared minus 4ac over 4a. So you might have seen an expression like this before in school or something like that. I've written that last term in a very particular way so that I can point at it in a second. So this is going to be 2 times first thing, last thing, 2 times, so foils or something like, I've got the first things there, and I'm going to do the last things next, but I need some inside terms and outside terms. Gives me something like 2 of these, and a b squared over 4a, which hopefully is going to go away. So this is just me checking that the thing I've written is true. Gosh, wouldn't it be embarrassing if the very first thing on the MAT livestream was false? Okay, so I think I've got this is going to be ax squared. Oh, phew, okay, this is a good start, and that's bx. And then b squared over 4, yeah, I've messed up. Oh, there's a squared, I'm good, I'm back in the game. And cancel the a, and it's going to be b squared over 4a. Phew, high stakes mathematics, let's go. Good, okay, phew, I think that's agreed. Interviews are online this year for the person asking in chat at Oxford, at all colleges. We've been doing online interviews for a really long time actually for overseas candidates, so we've actually got quite a lot of practice at those. Are we going to go through the homework, or will there be other questions? I'm just going to go through the stuff on the worksheet. You can ask other questions if you like, and sometimes I'm going to try and prove stuff. So just there, that little calculation is not on the sheet. Maybe it's the sort of thing that you tried when you were reading the worksheet. If not, maybe this is a nudge to try more stuff. Somebody else, an anonymous person in chat has given me, they tried to do this, tried to prove it, messed up as well. Look, I tried to write this. This is at least my 3rd attempt at getting that bracket correct. Right, okay. The reason that I've written it like this is because that first term is just like definitely positive if a is positive. So if a is positive, all of this stuff with the squared on is definitely positive or 0. So then if you care about whether the entire quadratic is positive for all x, the only thing you need to worry about is whether this last term is positive or not. And again, if a is positive, that's just a question about worrying about this last bit up here. Click. B squared minus 4ac. So there's that term, b squared minus 4ac. That's got a name. That's called the discriminant. The discriminant of the quadratic. Discriminant. Okay. Yeah, okay, good. And in particular, it tells you whether the quadratic has got any solutions or not, any real roots. Because if that last term, with that minus sign up front, if that last term is positive as well, then the whole thing is positive, so it doesn't have any roots. Okay, so I've got a little note in the revision notes there to say that, and I've got the quadratic formula, which comes from rearranging this to actually solve for x. If you care about this quadratic being equal to 0, then you can do some rearranging. This is the right form to write it in on the screen there. Andre asks, should you read the worksheet before the live stream? You can do, because I put them on the website before the live stream. You don't have to. I'm going to go quite fast. I'm not going to read out absolutely everything that's on the worksheet, because, oh my goodness, it's about, let's have a look. The worksheet is 7 pages. And this week, the solutions doc is also 7 pages. So I'm just not gonna read out all 14 pages of maths, even given 2 hours. This is beautiful LaTeX on the left. At the top, the bottom bit is my handwriting. Don't get I know they're very similar, but the top is beautiful LaTeX. Ooh, somebody wants a copy of the whiteboard. I just deleted a bunch of stuff. No, sorry. But the YouTube's going to stay here. I have to do some weird stuff with the whiteboard because I've got very small writing space. So I'm not going to take screenshots of this or anything. Okay, where is the worksheet? The worksheet A is at www.maths.ox.act.uk/r/matlive. Increment the counter. How many times will I get that right or wrong? I think I'm at 2-0 so far on spelling my own website. But don't worry, there's a link in chat underneath, and also a direct link to a web version. You can have a beautiful PDF up at the top there. So I'm scrolling through a PDF up here. Or if you would like a web version so that you can read it on like a phone device or something, there's also a web version. The Mat Live page has got both. And also solutions in 2 variations as well. Okay. Oscar's got some recommendations. I think Oscar was here last year, so I'm going to read out Oscar's recommendation. Oscar recommends going through the worksheet, including the revision questions, to check if you can cope, and then see what happens and join in. Okay. I've got on there somewhere the difference of 2 squares, which is basically my favourite quadratic factorisation. So once you've found some roots, you can factorise the quadratic. And in particular this one, which has got solutions a and minus a, factorises just really nicely like this, where in some sense this is just a true fact because you can multiply out the brackets first, inside, outside, last. Oh, the inside and outside terms cancel. You get this like a squared, x squared minus a squared. So it's just true by algebra. But in terms of sort of roots of polynomials, what this says is a and minus a are solutions, are roots of this polynomial on the left. And here they are presented as factors. So this is a kind of powerful way of thinking about roots and factors. Okay. What's a hard question about MAT polynomials? I've seen some questions which try to do multiple things with a polynomial, and maybe this is what the person in chat asks about hard questions with polynomials. Questions that try to do multiple things with polynomials at once, like talking about roots and also turning out turning points. Later on in the MAT Livestream, we're going to look at differentiation. Maybe you've already seen how to differentiate a polynomial, but we're going to look at that. And there's sort of some tricky things about combining both of those things together. In particular, when we get there, the idea that the gradient is 0 at a repeated root is a bit tricky. I think that gets a bit hard. Is it similar to TMUA? So quick shout out to our friends at Cambridge who also run a test. The test at Cambridge, it's called TMUA. I mean, they run another one as well. They run another test called STEP. MAT has got a similar syllabus to TMUA. So if you're planning to take that test, you might find these notes helpful as you're preparing. They've prepared some notes as well for people preparing for that. STEP is quite different. STEP involves lots more mathematics, not covered in this. But STEP has an entire series of worksheets called the STEP Support Program. And Timura is multiple choice only. Okay. So we've got notes here about the degree of a polynomial. And actually, somewhere in there, I added this for this year, the definition of a polynomial. So I realised that I've been doing this for a few years, and my worksheet about polynomials with the revision material never really told you what polynomial was. So there you go, that's the definition of a polynomial. And the degree of a polynomial, which I should probably have told you about before. Hey, this is my 5th time round. I'm going to assume this is your 1st time round. Hey, look, isn't it great that the notes say what the degree of a polynomial is? It's the highest power of x present in your polynomial. So I've got some examples there where I've tried to mix things up. And not really worth thinking about, but Constant polynomials have degree 0 because this is not really worth thinking about, but x squared plus 3 has got degree 2. X to the 1 plus 3, that's a linear thing, has got degree 1. And x to the 0 plus 3, well, firstly that's the number 4, because anything to the power of 0 is 1. It's got degree 0. I guess the 3 is also 3 times x to the 0. This is not really worth thinking about, and I don't think I would test people on recognizing that constant polynomials have degree 0 because it's not very interesting. But if you're interested, then that's your priority. You're allowed to be. Constant polynomials are considered to have degree 0. Constant polynomial, flat, the least interesting polynomials. Is step support helpful in preparing for the MAT? Yeah, a bit. The foundation modules for the step support program have got some useful ideas and some step questions. They existed before we started doing the MAT Livestream. In a previous life, I worked a bit on step support, and partly the inspiration for running a MAT Livestream is the support by the step people. But this has been built specifically for the MAT. So you can do both if you like. No one can stop you. They're both free. They're both just online. There's maths on the internet. Whoa. No one can stop you. Right. Did I mention this is free? I mean, it's obviously free. You're watching it now. But it's not like this isn't like a free trial before a subscription starts or something. It's just free. Right, good. Okay. Is the test the same in October as it is in January? There's only one test for MAT. It's in October. I think Tamua might do multiple test dates. I can't remember. I think there might be a question about Tamua from a minute ago. Sorry, I'm reading out questions from chat. I should focus on telling you about hidden quadratics. So some functions are not polynomials because they're not in the format of a sum of terms, each of which is constant multiplied by x to some power. But sometimes you can make a kind of clever substitution that makes it look like a quadratic or look like a polynomial. One that I've seen on a past MAT question, so I guess spoilers for a past MAT question, which uses powers quite a lot, is the MAT question talked about 2 to the x in the question, and it also talked about 8 to the x, and in the same question. And if you realised that 8 is 2 to the 3, so this is 2 to the x cubed. If you realise that, then things got much easier, especially if you write u equals 2 to the x, because then you have this. If you like, this is a whole bunch of 2's, and this is the same number of 8's, but each 8 is 3 2's multiplied together, so it's kind of 3 times as many 2's. 3 times as many of something is what happens when you cube it. So this expression really simplifies down to a polynomial. That was a good idea for one question I saw one time on a past MAT question. So hey, it's in the notes as a way to turn things into polynomials, so that we can start doing polynomial facts. For example, we could now start talking about factorizing this, right? To notice that this has a factor of u and 1 plus u squared. Maybe that's helpful for the question, who knows, but it feels like progress to simplify things down and rearrange them like this. I don't know, maybe we're trying to prove a bound on this or something like that. Okay, those are my revision notes. That's what I think you need to know about polynomials, which you'll notice is not very much stuff about polynomials. Okay, I'm going to switch to questions, I think. Good. So this is where it reveals that it's a PDF when I try and scroll past the page break. There we go, okay. So I tried to start the revision questions nice and easy to get you to sort of evaluate some polynomials and solve some equations. Let's do some of these questions. I'm going to pick out a few of them. If you want a particular question because you've already seen the worksheet, then let me know in chat. See, there's an advantage of doing the worksheet before the live stream. I promise to release the next worksheet quite soon, having made this point about how it's nice to do it in advance. So I kind of want to look at this x squared equals x plus 1. Historical comment, just a bit of history for you. Before algebra and before the way we currently think about quadratic equations, people thought of this sort of quadratic equation as being totally different to the ones where all of the terms are on the left-hand side. And they had a different sort of quadratic formula to use in this case. It comes a little bit with how you think about negative numbers, because probably you don't have a specific quadratic formula to use when there's x squared on the left and x plus 1 on the right. Probably your plan is to move everything onto the left-hand side. Sorry, I'm suffering slightly from a slightly laggy whiteboard, which makes my handwriting worse, and it's not great to start off with. So then if I get the quadratic formula out, I need minus b plus or minus b squared minus 4 over c. B squared 1 minus 4 times minus. I've done a lot of 4s and minus 1s there, but I've got this number. Hey, golden ratio. Fans of the Oxford Online Maths Club will have seen an episode about the golden ratio a while ago. That's the other show we run on Thursdays at 5 when we're not doing MAT Livestream. So I can see some requests in chat. So in particular, I can see requests for question 5 and question 18. Interesting. What's 5? Oh, it's on the screen there. Yeah. When does something have 2 solutions? Okay. And I saw 16 there as well. How am I going to remember this? I'm going to circle them on my physical bit of paper. 5 and 18 and 16. Okay, yeah, okay, good. Finally, golden ratio. Okay, so question 4 and 5 there are related. So you say, for which values of k does, in the first question there, x squared minus x plus k have exactly 2 real solutions? The thing to imagine here is that you have x squared minus x, which is a quadratic. Yeah, it's just slightly laggy. There we go. X squared minus x, which is a quadratic like this. So it's a 0 and 1. And then you're adding k to it. Of course, adding k increases the value by a predictable amount at each point, which moves the curve up. If you add k, if k is positive, I suppose. So maybe you saw that as I did that, I had 2 solutions, and then after a while I didn't. But this is daft, really. I shouldn't be messing around lifting things up and down, of course. I should be doing the discriminant. So the discriminant, which people sometimes call a capital D or delta sometimes, is b squared minus 4ac, and the rule is that if that's positive, then 2 solutions. So if this, then 2 solutions. Which says kind of what I expected, which is that if k is small enough, if you add less than a quarter, then you get 2 real solutions. But if you add a quarter, then that bit goes away. So alternative solution then. Alternative solution is to find out where this point is. Because if you find out where that point is, you'll know how far you can lift the parabola, how far you can lift the quadratic, before it goes into the positive half of space. What's the word for the upper half plane? Sorry, I threw myself by saying parabola. I told myself I wouldn't say parabola today, but there we go. And I ended up saying upper half plane. What on earth are we talking about? Okay, good. So you can find this tiny point. Anyway, the reason I've said that is because that is a good way to do question 5. I'm going to slide sideways. Ooh, but keep that. Haha. Question 5 asks about this quadratic. which is the same thing, but with x's replaced by x squareds. So if you like, this is a sort of hidden quadratic. So we've got different cases. If there are no solutions for u, then we can't have any solutions for x, because if there's no value for this u here, then I definitely can't find any values for x that satisfy this equation. Again, I want to write down the discriminant, b squared minus, if I've got an extra minus sign, minus 4b squared minus 4 plus, yeah, b squared minus 4k. So if this thing is negative, then no solutions. If it's positive, then you get two solutions for u, which is quite good, I suppose, except I wonder whether those solutions for u turn into solutions for x or not. There's different possibilities. Maybe they do, maybe they don't. Depends if u is a positive number or not, doesn't it? Okay. And there's a third case, I suppose, which is if 1 plus 4k equals 0, then one solution for u. And that solution will be, so in that case k is minus 1/4, that solution will be 1/2. And in that case you get two solutions for x, one solution for u, but two solutions for x, because x squared is equal to u, and if u is 1/2, then x could be either plus or minus root 1 over 2. Taking that square root, but plus or minus. I've gone slightly underneath. There we go. Yes, in chat, here we are. Aya says, only one solution for u because it's a hidden quadratic. But you get two for the actual x one. There you go, yeah. So that's this case. There's also this case where you get two solutions for u. Now that might turn into four solutions for x. Or it might not. It's tricky. So this is the case where k is smaller than 1/4. And there are two separate things that might happen, because I'm interested in whether those solutions are positive or not. Solutions for u. I'm looking at u equals x squared. I'm thinking, are these solutions for u actually positive numbers or not? So the solutions in that case are u equals, and I'm being really clear that these are solutions for u, 1 plus or minus root 1 plus 4k, which I've said is positive. So I'm in the positive case, divided by 2. That 2 is very small. There we go, okay. I'm interested in whether that's positive or not. And the one with the plus sign definitely is, because 1 plus square root thing is positive. So I'll get a couple of solutions there. But the one with the minus sign might be negative if the square root is bigger than 1. Which actually means that if k is bigger than 0, then this square root here, 1 plus 4k inside, the square root here is bigger than 1, which means that when you subtract it, you get something negative, which doesn't give us any solutions for x. So there's this kind of chain of reasoning here between solutions for u and solutions for x. I'm trying to be really clear about whether I'm talking about solutions for u or x, because those are different things. It's very easy to get confused if you just write down quadratic formulas and if you just write down the discriminants. So if you just write down these, and if you just write down this right-hand side, it's very easy to get mixed up about which one you're talking about at any point. Good question. Is k positive in the original quadratic? I don't think it says k is positive anywhere. So I'm considering both. Yeah, so if k is positive, then sure, you get two solutions for x. If k is negative, then you get four solutions for x. Graph, quickly, just to think about this in terms of a graph. If you like, this is taking the graph x to the 4 minus x squared, which looks like this. So being able to draw different polynomials is a good skill to have, because it gives you a way to visualize it. So here's x to the 4 minus x squared. Quick tips about drawing polynomials. When x is very small, it's the smallest powers of x that matter, because small number to a high power is tiny. It's not important at all. So this x to the 4 hardly matters at all when x is small. It's way, way smaller than x squared. Maybe x squared is small, but x to the 4 is like small times small, so it's tiny. So this looks like minus x squared, which is why I've drawn it curving down when x is small. But it's the other way around. When x is a very large number, if x is a very large number, it's the highest power that matters. So that's why I've drawn it pointing up like this, because it's x to the 4 points up. So tips for drawing polynomials. When x is small, it's the lowest power of x that helps you decide what the behavior is like. When x is very large, it's the largest power of x. And you remember that by remembering what happens to x to the n when x is very large or very small. I guess for different values of n. Ugh. Yeah, no, you'll be all right. Okay, that's a good tip. That's a good tip. Okay. Oh, is it plus k, not minus k? Oh dear. Oh, is it plus k, not minus k? Oh dear. Yes, it is. Oh dear. That's why they said k was positive. Bother. Bother, bother, bother. Bother. Right there. Right there. Oh, did I do it in the previous one as well? No, I got it right in question 4. Oh, painful. I almost made it to 6 o'clock without getting a minus sign wrong. Okay, everyone, let's quickly fix some minus signs. Maybe this is an opportunity for me to demonstrate how important it is to be able to correct your own work. Because I could start again, right? Or I could just go plus, plus. Over here I meant b squared minus 4ac, so minus. Was it minus before? Oh gosh, I meant minus before. Oh dear. Minus, minus, oh goodness me. Minus, minus, minus. Negative, positive, switch these two around. Oh, it's everything. Oh no. Sorry everyone. I'm not switching on chat right now because you can imagine what chat's like right now. Oh, let's change the question a little bit. Oops, oops, oops. Sorry, somebody's put their username as Fermat Small Margin, which is a cultural reference. Man, I thought I was wrong for getting positive K. You're not wrong. You're just able to read. Yeah, bad at reading questions. It's worse because I wrote the question. Right, cool, okay. We learn and grow. I would have spotted it in a second look because, well, maybe I wouldn't. Here's x to the 4 minus x squared, and then adding k has the following effect. It currently has 3 real solutions, which is a bit weird. If I add a little bit of k, positive k, then I get 4 solutions, except, brief exception, k equals 1/4, which is this number over here. Oh, hey, there we go. K is 1/4. Solution is actually 1/2 in that case. Good. And x is like these numbers here, plus or minus 1 over root 2. So if you thought about the graph, you might have found these minima of the graph being the important point. If minima of the graph doesn't mean anything to you, don't worry. We're doing that in a couple of weeks. It's all joined up, right? It doesn't matter where I start. It's all joined up. And then, sorry, if I increase k a bit more, then there's bits of the top. Also, if I decrease k, then I tend to get 2 solutions for x for a different reason. They're like this. They're a symmetric pair of solutions. And it's 2 solutions, not 4, because where there would be 2 more solutions, well, they've gone down here now, it's all square root of negative numbers stuff. Won't there be 4 sometimes? Yeah, so in this case, there are 4 sometimes. I got the sometimes wrong over here because of my minus signs. But the idea there is that, yeah, sometimes there are 4, like this sort of case. So I add on a bit of k. Then sometimes there are 4, which comes from, deep breath, comes from turning the original equation into a quadratic, solving the quadratic, and then checking whether the solutions for you, for that quadratic, whether they correspond to actual solutions for x or not. Because for each one, if u is a positive number, it gives you some x solutions. If u is a negative number, it doesn't give you any solutions for x. Polynomial inside a polynomial, chained together. Okay. There's also a user called Real Format. They've just met. They're doing the standard exchange. People watching the replay can now just imagine what that's like. There you go. Exactly 2 solutions. Yeah. So there's 4 sometimes and 2 sometimes. This tiny bit down here is when I was running out of space and I started thinking about 1 minus 4k and 1 plus 4k inside here, whether this square root would be bigger or smaller than 1. So whether the effect of adding and subtracting it would give me negative numbers or not. Running out of space, you see, I can do it too. Right, good, okay. I'm going to move on from 5. I think if you want to see a more sensible bit of working out in the sense that it doesn't have any minus sign errors, you can check the solutions doc on the MAT website. Or to be honest, if you try it yourself, then you're probably more likely to get the minus signs right than me. Right, there was also a request for 16 and 18 I saw, so let's scroll a bit. There's 16. So here's the sequence. I saw this one past Matt question with something which was polynomial in disguise. I put it on the revision, and then I wrote a revision question to try and get you to spot the polynomial in disguise. This question doesn't really work because I've given you too much freedom. We'll talk about that in a second. But what you can do here is in each case there's a choice of substitution or change of variables that lets you rewrite these things as a polynomial. So for example, this first one is this with u equals x cubed. Do you see what I've done, right? That first polynomial looks like a polynomial of degree 6. It is a polynomial of degree 6, but if you write it in terms of u, where u is x cubed, then now it's a quadratic in u. So there you go. The next one is a quadratic if you think that u is root x times root 2. Whoops. Almost tricked by my own question again. X. The third one has got some exponentials in it, but the second one is kind of pretty much the square of the first one. We'll talk about exponentials in a future episode, but that power there works in the same way that you see powers on x's and things, right? If you square the expression, the power doubles. So if I write this as something like 3u plus 6u squared, maybe, with u equals e to the minus 3x, and this is where the question doesn't quite work, right? Because you might have chosen to put the 3 in as well. There's nothing wrong with that, to include the 3 over here, and I guess divide by 9, which is sort of like you might have spotted there's some 3's in common as well. So why not put them in u? There's nothing wrong with that. I guess you would move this 3 over here, and you'd remember that that's actually now u over 3, so this is like this over 9. Nice. Okay, yeah, last one using like partial fractions or something. This last one is a bit hard. The thing I was thinking of when I put this on the sheet is that 1 plus x, we could simplify this fraction if we had 1 plus x in terms of 1 minus x. I'm not really sure this is going to be, I don't think this is going to go down well. Okay, I'll give it a go. So what you can do is you write this as 1 minus, so it's sort of like 1 minus x, except it's not that, it's minus that. And it's not that either, is it, on the top? We're getting closer, but it's not that either. It's that plus 2 over 1 minus x squared, which means that this is equal to 1 over 1 minus x plus 2 over 1 minus x squared, which then looks a bit like a quadratic because the second term looks a bit like the square of the first one. But I feel a bit mean putting this on the question sheet, because who would do this? Who would replace 1 plus x with minus 1 minus x plus 2? Answer, people who have seen partial fractions, but probably no one else. Ooh, x minus 1 plus 2. Yes, that's true. X minus 1 plus 2. Good. Thank you, Anonymous. Thank you. If you set x as 1, then the denominator is 0. Duh. Good chat message, love it. I'm very suspicious of this partial fraction business. Oh no, the cover-up rule is the thing I don't really like. It's not on MAT syllabus, don't panic. No partial fractions today. I used 1 over 1 minus x. Oh yeah, that's a great idea. Yeah, that's really good. Yeah, that's exactly what I want to do. No partial fraction stuff. Yeah, good. Brilliant. Okay, there's an anonymous person in the chat who did this question with the way I wanted it to be done, without thinking about partial fractions, for which I think they deserve some sort of gold star. I don't have the ability to post gold stars. Oh, hang on, maybe I do. Can I star it? I can go bing and paint it a lovely colour. There we go. Briefly. Okay. If you're in chat, you briefly saw that comment. Glow like the sun. The reason this question really doesn't work, and why we should all just laugh at it and move on, is that if you just call this thing u squared, where u is the square root of 1 plus x over 1 minus x squared, then now it's a quadratic. It's now u squared, right? Where u is this horrible expression. So yeah, done. It was a hidden quadratic, guys. It was u squared with u equals blah. So this question doesn't really work. And can't use this. Can't use this, or can't use this on the mat. So the person in chat asking, will you get extra marks in the mat? No, that's not coming up. It's quite hard to write these questions without the extra context about why you might want to do this. So root x is quite nice because it's a simple function. E to the minus 3x is a simple function. Maybe if you had some other tasks to perform, there might be a reason why this is a nice looking kind of function and this is hideous. I don't know. I feel bad for it now. It did suffer particularly from my handwriting going pretty bad just there. Okay, one more, which is there was a request for 18. Yep. Double root. Okay, so double root is when a polynomial v of x. So double root is when it has a root twice with the same value, which people normally write as that thing squared. But I want to stress that just for the point here, I want to stress that if you can take out the factor twice, that's a double root. There are lots of nice facts about double roots. For example, the derivative there is 0, but we haven't done differentiation yet. So what I'll do instead is to note that if x minus 1 is a factor at all, then by the factor theorem, it should be the case that v of 1 is 0. So if I plug in 1, then I should get 0, which gives me this equation. Now it's also true that at a double root the derivative is 0, but I think what I should do is I should pull out a factor. So what I'll try to do is pull out a factor from v of x, because I can see the expression for v of x there, so shouldn't I just try to factorize it, right? X squared, and then, okay, so I've got this way of doing polynomial division. Not everybody likes this. I'm going to do my way of doing polynomial division. If you're watching at home and you've got a different method of doing polynomial division, that's fine and valid. This is what works for me. I write down the factor, and then I start writing down terms over here, right? So I write down x squared because I want to see an x cubed, but that will give me minus x squared. Oh no, I don't want minus x squared. I want minus 2x squared. So I fix that by writing down minus x. Writing down minus x will give me, you see, another minus x squared. But that creates a new problem, because now this will give me plus x when it multiplies with the 1. And I don't want x. I don't want x. I want a times x. So I'm going to add on a minus 1, because that will solve my problem to give me a lots of x overall. But oh no, that'll give me negative 1 times that when I multiply out. But that is equal to... Has this worked? What am I doing? Has this worked? Yeah, I think this worked. That's equal to b. Possibly. wanted +2. I've missed another minus sign. Oh dear. Oh dear. I've missed another minus sign. Ah, the irony of saying this works for me just before it doesn't work for me. Okay, one more time. I've got an x cubed and I want +2x squared, so I've got to add on 3x. There we go. But then I'll get minus 3x. I don't want minus 3x. I want ax, so I should add on a minus 3, so that I get a minus 3x. So overall ax, which then, haha, brilliant, gives me a last coefficient of 3 minus a. Oh, come on, I can do this. What is wrong? What am I doing? Help. I'm going to take a quick break and look at something else. Yeah, I should just multiply out and equate the coefficients. I'm being lazy. That's the thing, being lazy is sometimes my undoing. Because when I'm being lazy, I tend to make even more mistakes than when I'm not being lazy. Minus x squared, so I add on the 3x squared, and I subtract the, because I've got minus 3x. Minus 3x. So I need to add on a plus 3. It's another minus sign error. They're my favourite today. I will make minus sign errors left, right, and centre. This is okay, this is true. Phew, finally got there. Good. So double root. It's just a matter of plus and minus signs, wasn't it? Top comment at the moment. I'm going to stick with polynomial long division. Yeah, fair enough. So also we want 1 to be root of this thing, which is something like that. 1 plus 3 plus a plus 3 should be 0. Which actually gives me a value of a. And then we're off to the races. There's a grid method as well. Yes. Oh, Oscar was telling me it was a plus 3 and I missed the message. Okay. Thank you, chat. Right. If you've been looking at the screen constantly for the last hour without blinking, then maybe now is a good time to blink. Otherwise, I guess if you don't want to blink, then I can't make you. I'm just going to check my numbers for this one. I'm really scared. Yeah, minus 7, and then B is 4. Okay, right, wrapping this up. A is minus 7, and then way back up here, 3 take away 7 is 4, minus 4. So then over here, B is 4. Wow. Okay. Ooh, you solve the formula. How do I feel about this? I do like the idea of trying the other route. Okay. Whew. I've made 3 minus sign errors in an hour and a bit, which is not unusual for me, but it's an interesting start to the Oxford Online MAT live stream. Ooh, Shrisht has Syrup, sorry, has got a different solution. I like it when there's a different solution. Just set v equal to. So their idea is that they actually know what q of x is before I do all this like work. I had it as a kind of mystery up here for just what does a double root mean. But they've noticed that v has got degree 3, so q has got degree 1, x, and so only one more x. And in fact, you know what this polynomial has to be just by comparing coefficients. Everyone was telling me to compare coefficients in chat. So I think chat was pretty certain that this term over here would be x plus b for like the leftover stuff, so that the last coefficient works and so that the first coefficient works. And the middle ones have just got to work out. And what you could do is then multiply that out. And just see what happens. So alternative. Oh, that's off the screen. Alternative, just multiply out x minus 1 squared x plus b. So you know the other root is minus b, which is something some people know loads of relationships about roots and coefficients. But just multiply that out and compare the coefficients. Pretty nice. Okay. Good. Okay, somebody has now registered the username. Fermat's trivial proof, which works well with a small margin. Okay, let's actually do this. There's a request in chat to multiply this out. Now, my polynomial division might be a bit weird, but my polynomial multiplication is pretty normal. Equals this, and then that's going to be x cubed. Oh, here we go. I've set myself up to fail here, haven't I? Last, there's going to be a b minus 3 here. No, I'm way off base, aren't I? No, I'm b minus 2. X squared. I get bx squared like that, and I get minus 2x times x to give me another minus 2x squareds. I'm going to get some x terms, which is going to be one of these minus 2b. So I'm doing this with some mild chaos by trying to multiply it out and also group together like terms at the same time, which is a bit of jeopardy. Okay, so coefficient matching. If two polynomials agree for all values of x, then their coefficients are the same. Hey look, b is equal to b. Great news. But more interesting news, b minus 2 is equal to, what was it, 2, wasn't it? Okay, right, focus. We can do this. Come. B minus 2 is equal to 2. So b is 4. And then 1 minus 4 is negative. I don't even know anymore. 1 minus 8 is minus 7, which gives you the value of a. Compare the coefficients. Hooray! And actually they read off quite nicely without having to solve any simultaneous equations. There's something really powerful about saying what this bracket is in its entirety. To say exactly what this is. Yeah, thank you, chat. Is this question more like MAT MCQ? I like the way there are a couple of ways of doing it, but MAT multiple choice question might make you do something a little bit more unfamiliar. So it seems like lots of people in chat are good at double roots and multiplying out polynomials like that. Let's have a look at a MAT multiple choice question now. Here's one. So I've modified it a tiny bit for the MAT Livestream. And if you get the PDF or the web version, if you get the worksheet from the website, then you can scroll down to get some hints for this multiple choice question. But here it is. It's a pretty horrible looking polynomial with terms like 3 plus x squared to the power of n. And over here, x plus 3 to the n, x minus 1 to the n. So this is a polynomial of degree 2n, or is it? Yeah, chat, what's the degree of this polynomial? Is it a polynomial? Yeah, it's definitely a polynomial. How did I know it's x plus b? Oh, I guess because I'd already started comparing coefficients in my head. Maybe I should have called it x plus c for some unknown c, and then it would have turned out at the end, by comparing that last coefficient, that c was equal to b. But egged on by chat, I worked out what the last coefficient was going to be, that last thing without any x's, which is a bit like plugging in x equals 0. Think about that last coefficient, which is just minus 1 times b, because I knew it was the number b at the end. Oh, you're getting a building construction noise. Sorry, there's some noise going on. Modified, in this case I modified it to make it easier. But, you know, when b squared is smaller than 4, how do you find b? In question 6, if b squared is smaller than 4, there are no real solutions, right? Yeah, there are no real solutions in question 6. First insect to try 2, 3 and 4. Yeah, okay. Yeah, okay. See if it works for small values of n. Who knows? Maybe it'll just work for all n. It's a good instinct. Lets you try some stuff. Multiple choice questions have this thing where you can use the fact that one of the options is correct. So I think it's not degree 2n, by the way. I stopped myself from saying it was degree 2n because the x to the 2n from this bracket is going to cancel with an x to the 2n from these brackets over here. Look, x to the n and another x to the n. But I reckon it's probably got degree 2n minus 1. Probably. Okay. Do I consider 0 even? Yes, I do. It's 0 is even because it's a multiple of 2. Okay. Well, in this question, though, n is a positive integer, and I'm not sure I consider n to be positive. It doesn't really matter. What happens if we put 0 in? Oh, then we're going to argue about whether. We're going to argue about whether the 0 polynomial has any factors. Ooh, yeah, let's not argue about that. Okay, let's say that n has to be bigger than 0 for this modified question. Here's what's going on. We're looking for whether x plus 1 is a factor, which means we should try, if we give this a name like p of x, we should ask ourselves, is p of minus 1 equal to 0? So factor theorem, if this really does have a factor of x plus 1 times q of x for some q of x, then plugging in minus 1 will definitely give us 0 without even having to think about what q of x might be. Plugging in minus 1 will just like eradicate all of that by making the bracket 0. And plugging in minus 1 is something we can just do. See, I'm being more careful now. Half an hour ago, I might have just written down minus 1 squared is 1, but now I'm trying really hard not to make any more plus and minus sign mistakes. So this is 4 to the n, and this is 2 to the n minus 2 to the n. Okay, minus signs and errors are going to be all the rage here, aren't they? So the question is whether this is this 0, is this 0? It does say positive, yeah. There is some cancelling in this. There's a question in chat I've seen about locations of test centres. I don't know where all of the test centres are. When registration opens, there'll be a tool for finding test centres, and there'll also be advice about what to do if there isn't a test centre anywhere near you. Okay, so the question in chat, which I'm going to put on the screen, just because it feels like I've been missing having chat on the screen for a moment here. I've got the tech tab chat on the screen, there we go. I see it covers up the question, right? And it covers up a bit of my working out. After plugging minus 1, can you not take a minus 1 to the n out and evaluate the cancelling like a sigma notation oscillating positive or minus to get the remainder as 0? You see, when I read that, it sounds a little bit like a request for me to please don't take out the minus 1 to the n. No, I'm absolutely going to take out the minus 1 to the n. Yeah, absolutely. Great stuff. Yeah, so here's a bunch of minus signs. Sorry to be silly. It's something my students do as well. When my students are not totally sure, they say, can I not do this? And I always think you could just do it. You don't have to ask permission to not do it. Just go for it. There's no you don't need my permission to just go for it, as long as you're doing something true. Good, yeah, bring out those minus 1s, great stuff. So then we're done if and only if this term is 1, which it does when n is even. Good, okay. Sorry to make fun of the anonymous person in chat. I'm only teasing with the kind of negative. Think positive. Can do this. Yeah, okay. So checking odd and even separately is another suggestion in chat. And here's an interesting question in chat. Do our justifications need to be professional, using the right vocab and such? No. We know that people are taking this test from lots of different educational backgrounds where people have different names for things and different vocab, so we're not going to sort of require you to use our words for everything. We're much more interested in your reasoning rather than the precise vocabulary use that you've got. I've been joking a little bit about arguing about whether the degree of a polynomial is 0 or not, because these kind of fine distinctions do matter for mathematics, but the questions are mostly looking for you to have ideas and to make progress with the questions. How did you get that last line there? So what have I done? Slow motion replay of nothing. There's no football here. What are we talking about? Sorry, slow motion replay. This is, I saw this bracket and I thought, I know what that is. That's -2 times -2 times -2 times -2. I'll take out all the minuses separately and all the 2's separately, because minus times 2 times minus times 2 times minus times 2 is minus 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 times 2, 2, 2, 2, 2, with n of each of those. And oh, I just wrote this down right. I know that 2 to the n times 2 to the n is 4 to the n. I guess because I know and I'm happy with this fact that you can do things like this. So I stuck the 2's together to give me 2 times 2, that's 4. And also because I was I was looking for it because I had a 4 to the n here and I wanted 4 to the n there. That is the slow motion replay of what happened in that last line there. Do let me know at any point if you want a slow motion replay where I try and explain what I was thinking at the same time. I'm not trying to be patronizing, I'm trying to explain what I was thinking as well. Okay, good. On this question about competitions, if you've done other competitions, you could talk about them in your personal statement, but you don't have to do other competitions. Not everybody gets the same competitions as each other. Some people have done quite a lot of competitions and seem to enjoy it. Some people don't enjoy it that much. So, yeah. Different things for different people. Personal statements are personal. Okay, how are we doing for time? Not great. It's probably because I spent 25 minutes just talking about how excited I was about MAT at the start. I'm not going to talk about this one on the live stream, but if you want to draw pictures of polynomials, here's a good question to get you practicing drawing pictures. And again, it's really important that you think about what's going on for small values of x and for large values of x. So the thing I said before about what's going on for small x and large x really matters for this question, because whenever these curves switch from one being larger to the other being larger, that's going to increase the number of regions or the number of areas in here. Real FirmAt, who I think said they applied last year and they're just here for fun, has asked for a fast motion replay, which is cheeky. And what you can do is watch the recording of this live stream at double speed, like all of my students do. Are you compared with other people from your school? Not really. Usually we don't have people from the same school for most schools, so it's not really a step we can do. And also, as I said at the start, we're looking for individual people who would be good on our course. We don't necessarily need to try and do an in-school comparison. We're going to do the maths admissions test, which is a bit of a wider comparison anyway. Okay. So I know it's very tempting. I know it's very tempting to sort of compare yourself to the people immediately around you, but I don't think it's a very healthy way to live, especially if your comparison is to just be really like binary, yes, no, am I winning or not? I don't think that's a great outlook, and that's not how Oxford tutors look at you and your friends. Right, okay, here are some hints. If you want hints like this, they are briefly on the screen. We just did the question, so oops. But too late now, I guess. Here are some hints for the sketching. Things to think about when you're sketching. If you would like to see the hints before I start talking about the questions on the live stream, they're in the worksheets. That's where to find them. I think it's time to talk about a MAT question. So I've got one here. Here we go. Yeah, I think we've got there. MAT question. I've got a couple of these. I want to talk about both of them, I think. I think I've got time to talk about both of these over the next half an hour. Yeah, we do bits and pieces of both of these. Good. Someone's just got back from work experience. What you can do is you can join in live if you like for the MAT questions. It's a perfect time to be joining in if you want to see some MAT questions. I think YouTube also lets you rewind, so if you want to see the last 40 minutes and also the previous 40 minutes, then you can rewind, play it at double speed, and you'll get to the end at the same moment as me. Right, this is the real technology, is to join in the middle, rewind it, and then watch at double speed to finish at 7 o'clock. Okay, I'm joking aside. The recording is not going anywhere. The recording is just on YouTube for if you want to watch it at the weekend instead. If Thursday's not a good day for you. I've been doing these on Thursdays for so long that I can't actually remember why we do them on Thursdays, but there we go. Okay. There's a question about football. I'm not going to talk about football. Okay, right. This is nice, isn't it? We're setting the ground rules. We're not going to swear or divide by 0, and I'm personally not going to talk about football. I don't mind if you do, but I'm not going to talk about football. Okay, so I like this as a follow-up question to the thing we were just talking about, because look, it's got another -2 to the power of n, just like the one we were just talking about. There we go. I've written it out, of course for you it's at the top of the screen, but now I've got it, and I wanted to really make sure that I had all of the minus signs right, because you know me. Right, okay, first part of the question wants us to write down f3 of x, which is good practice at working out what on earth this notation means. So here we've got f with a little subscript, and the subscript is called n in this general expression, and it appears on the right hand side in some places. So if you like, for each value of n it's a different function. There is f3, there is f2, and there is also f1, the fastest function. But we're going to start with f3 and work our way up to have something like this. So what this means is everywhere you see an n, to replace that with 3. Oh my goodness. Thank you, Ira, in chat. I pointed at it, I checked, I said, you know me, and I was wrong. I missed an x. Oh, great. Okay. I picked it back up, though. There we go. I think I did this worksheet last week. We put this worksheet up last week. We also put a very similar worksheet up last year. So there you go. And the question also says that they want the maximum value of f3 of x. That's interesting. It's got a maximum value. Oh, I suppose this thing here is -8. So this is minus 6x squared plus 6x plus 9. So to find its minimum value, we could differentiate. That's something we do for lots of functions, but this is the polynomial live stream, so I think I should have a go at completing the square. Up to you. What do you think we should do, chat? Let's let live chat decide. Should we do the maximum value by completing the square or by differentiation? I can see advantages and disadvantages of each. Suggestion, one person's got a suggestion in chat. Differentiating is faster, complete the square works. And somebody says differentiate maximum when x is a half, and then substitute that back in. So this is part of the work, is that we want the value of the function, not just the location of the maximum. People in chat, I'd say it's 50-50. Or if I add together the thumbs ups, though, you can give thumbs ups in chat. Just to show you what this looks like. It's pretty 50-50, isn't it? Okay, good. But there's quite a few votes for complete the square, so I'm going to do it like that. I accept that differentiating and then plugging the numbers back in works. The reason I might not complete the square, I think, is that I have to deal with this factor of like -6. So maybe people in chat have got advice about how to deal with this in a different way. You know, would you deal with the -6 as you go through, or would you, like me, pull out -6 first and then try and just deal with this one inside here like this? So I'm trying to forget about the -6 out the front by just dividing everything by 6, which I think I've done correctly. Yes. So quarter, but I want -3/2. So I need to subtract, oh gosh, quite a lot, don't I? I need to subtract that 6 quarters. I need to subtract like 7 quarters. Have I messed up? I feel like I've messed up. Completing the square, it is less intuitive. It does fit the polynomial vibe. I agree with that person. What have I done? Am I just correct? So for me, there is also a challenge of trying. I get haunted sometimes by the idea that I've seen the question before and it didn't go the same way the last time I saw it. So only at minus 7 over 4. Minus 7 over 4. And the whole thing's multiplied by minus 6. So my minimum value is when x is 1/2. This thing, this minus 6 times minus 7 over 4, is 21 over 2. I think I saw someone in chat say 11 over 2. Not sure. Okay. So I think I get 21 over 2. I've definitely got a factor of 7 in here. It's minus 7 over 4. Anyway, okay. The question asks us, for what values of n does fn of x have a maximum value? And that's interesting because, well, if I look back at fn(x) up here, it's asking us whether this has a maximum value or not. So I could differentiate. I could do a second derivative to talk about maxima or minima. But really I want to think about, well, this is just a quadratic, right? So the thing that makes a quadratic have a maxima or minima is really just the sign of that first coefficient, the one in front of x squared. If it's positive, then this is a happy quadratic that has a minimum. And if it's negative, then this is a sad quadratic that has a maximum. It is 21 over 2. Thank you so much, Hannah and Trisht in chat. Good. I got very nervous when I saw the number 21 over 2. But we're good, I think. So this is a quadratic. I think it's got a maximum only if it's a sad quadratic, which only happens if that thing is negative, which is true when n is odd and bigger than 1. If it's equal to 1, this is a linear function. If it's even, then this is some huge positive number. And if it's odd, then this, if n is odd, then this gives us a very negative number. Think about small values again. Yeah, coefficient of x squared. Shouldn't be 0, should it? Shouldn't be 0 for this to have a minimum value. If that coefficient is 0, then really you've got a linear function, and they don't tend to have maxima or minima. Okay, you're not being asked to calculate the value of this maximum. That's nice. Yes, I would not want to. Okay, I think the rest of the question, or a lot of the rest of the question, is about f1. So let's up the speed a bit and take part in f1. F1 is quite simple because f1 is precisely where that minus 2 to the n is minus 2, which cancels the 2. So that leading thing that says 2 plus negative 2 to the power of n, quick look up the top, 2 plus minus 2 to the power of n, that's 0 when n is 1. So f1 is just 4x plus 1, which is rather nice. And then they want this notation where they have nested brackets. They're imagining taking the value of the function and plugging that into the function again. There is some absolutely brilliant mathematics in general from plugging a polynomial to take the output from a polynomial and plug it back into the polynomial and loop that round and round and round and ask the question, what happens when you do that lots of times? There is some beautiful mathematics to do with that, which I think we're not going to do right now. So this would be, the rule for f1 is you do 4 times the input plus 1. Here the input is itself f1 of x, which says 4 times the input plus 1. And that second time as an input is actually where the x is. That's kind of taking the shape of f, but the input now is itself 4x plus 1. Okay, I can probably simplify that. It's something like 16x plus 4 plus 1. 4 plus 1 is 5. Welcome to the MAT Livestream. The next thing they want is 3 of these together. The left brackets are the ones which really don't work. There we go. If I really concentrate on the left brackets, I can get those to work. There we go. Which is 4 times that. I immediately forgot how to get left brackets to work. 4 plus 1. But then plus another one out here. So it takes the input now is 16x plus 5. Drop it in there. I'll put in there to get 64x I see. So each time I do this, the coefficient of x goes up by 4, and I get another term out here. It's 21 now. And the question wants us to do this k times, which means to spot the pattern here. And the pattern is that each time this gets multiplied by 4, so this is 4 to the power of k, and these terms are a geometric series. We've got an episode about geometric series coming up in a couple of months on the MAT Livestream, so we're going to work through the syllabus. It's the last thing on the syllabus. So being able to do sums like this, where there's a common ratio between the terms. Each one is 4 times the previous one here, to be able to do this. Good. People in chat have worked out what I'm talking about repeatedly doing a polynomial. There's some 3x plus 1 has been mentioned in chat. Good times. Okay. Right, what are we doing? We're, for the last part, going to write down f2 and talk about the degree of doing f2 lots of times. So the degree of the polynomial is the highest power of x that you see, and I need to write out what f2 of x is. So I think this is probably a quadratic, because it's 2 plus minus 2 squared x squared, looking back to the definition of f(n)x, plus n plus 3 is 5 in this case, x plus, and then n squared is 4. Which, that's 4, so this is 6x squared plus 5x plus 4. So then we're asked to imagine what happens if you do f2 repeatedly. And each time we do that, we're going to square the previous thing, multiply by 6, plus, this stuff with 5x plus 4, but we're going to square it and multiply by 6. The squaring there, well, you get lots of things when you square, but the highest power of x is going to come from whatever the previous highest power of x was, squared. So for example, if I put this quadratic into f2x, if I start applying f2 again, if I put this quadratic in, then that x squared term will get squared. I'll get x to the 4. Then if I put that in, it'll get squared, I'll get x to the 8. No, yes, no, yes, no, yes. Squaring keeps multiplying that power by 2. So I think the degree is 2 to the k, because it keeps getting multiplied by 2 if you do this k times. And it starts out at 2, and each time you keep squaring, so you get kind of x squared, 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 dot, 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 squared. Oh, I should close my brackets. 1, 2, 3, 1, 2, 3, dot, dot, dot. Where there are k squares, I think those will get multiplied together to give a power of 2 to the k. That's all I care about. I care that its coefficient is non-zero, but its coefficient is like a whole load of 6s. Should we work out its coefficient? Did I set this as an extension? I don't think I did. Let's work out its coefficient. That seems like fun. So if you put all the 6s in, what happens? Sometimes on the worksheet, so I just had a glance over, on the worksheet I've tried to come up with like extension questions, which are just there for fun. They're not part of the MAT question. Oh, no, I did. Yeah, I have asked this. Over here, what's the leading coefficient? Yeah, there you go. I have done that. That's an extension on the sheet. So if you want to work out what happens when you put all the 6s in, that's something for you to think about as an extension. Right, cool. Be looking at the wrong place. Why is it 2 to the k, not 2 times k? Yes, it's misleading, isn't it? If you look at the first couple, the sequence goes 2, 4, and you think, this is just multiplied by 2. That's why I really paused and said yes, no, yes, no, yes, no quite a lot when I said 8 for the next one. So x squared squared is definitely x to the 4. We all agree on that. But then a question about what x to the 4 squared is. Is x to the 4 squared either x to the 6 or is it x to the 8? I think it's x to the 8. because it means x to the 4 times x to the 4, which would be 8, because it's all multiplied together. Generally, these powers, if you have powers like this stacked together, then they get multiplied together. But I agree that when you see the first two terms of that sequence, x squared and x to the 4, you kind of think, well, it could be either, couldn't it? And there was a bit where I said yes, no, while I thought about it lots of times. Those were the two things I was thinking about, 2 to the k and 2 times k. There is no formula booklet in the MAT, sorry. I think if there was a formula booklet, the only thing it would have in it would be the sum of a geometric series, which I think you can learn. I think that's the only thing I'd put in the formula booklet. Yeah, not putting the quadratic formula in a formula booklet. You know the quadratic formula. And you should know the sum of a geometric series as well. I think it'd be alright. Is the coefficient something like that? I think it might be. I think there's a geometric series, which means maybe I shouldn't have maybe I shouldn't have asked you about that. Yeah, something like that. 6 to the 2 to the k or something. People in chat are trying the coefficient question. Okay. This is a math question. The thing I want you to notice is that it's got several different parts, but they're all related together. And not so much in this question, but sometimes you might build on an idea between the different parts. There's also a little bit of explanation. So in long questions, you should expect to explain something or justify something. So here, you should probably justify if you were doing this question in 2007. This question's from 2007. If you were doing this question back in 2007, then you would probably describe the degree there a little bit. Answer the last bit of question 2. This one, 2007 question 2. The last bit, the degree of this polynomial, if you do f2 lots of times, is 2 to the k. It's kind of, and this will look weird, but it's kind of like this thing here is x to the power of 2 to the power of k, where I have to put brackets in there so that we don't get confused about which thing's being raised to the power of what. Brackets are not associative. Okay, I've got one more question that I want to talk about before we get to 7 o'clock. If I don't make it through the question, don't panic. Questions are on MAT Livestream, including solutions, very detailed solutions that I wrote in advance in case this happened. But I do want to talk about another question. Last things before. Last things before we move on. Oh, last part of part 2. Ozzy would like the last part of part 2. No, did I not do this? I might have skipped it. Oh yeah, I skipped the geometric series. Sorry. So if you do this k times, then you'll get 4 to the kx plus what's this? This looks like 21 is 4 to the k minus 1 divided by 3. Where to do that sum, I've used some geometric series facts, which I think not everybody knows, but we will get there. Questions about 24, really. Questions about 2024, so not 2007. Look, I won't ask, but I've been using this question from 2007 for a while, and there's a chance that at some point I'll start talking to people who were born after 2007. You know, at some point. Not too long, I guess. The people born after 2007 will start looking at this question, which is a bit scary. But hey, would I recommend doing the long questions or multiple choice questions first? I think I recommend multiple choice first, but keep an eye on the time and do try the long questions. For some people, they'll want to do the long questions first, just to get them out of the way or to see what they are. But there's a fair few multiple choice questions. Lots of those as well. Here they are. This day has come. Quick look. This day has come. I have met somebody born in 2007 who is the same age as this math question. I knew it would happen. Nice to meet you. Good. Time limit for 2024, it's a 2.5 hour test. And there's a question about whether multiple choice questions are harder than they used to be. I don't think I can comment. They're not. I don't want to comment on what the questions are. I don't want to say what the test questions are. There's no reason for us to make the math experience harder than previous years. We're still trying to test the cohort of people applying, so it's not supposed to be a major change to the test. Look at that balance. They're in year 12, about to send out applications. That is the year. Here it's happening. Yeah, there you go. There you go. Okay. Right, one more math question, I think. Oh, this question got a whole page of hints. I wrote these a couple of years ago, I think, for hints. Okay, right, 2011. This is a good question. Oh, I really like this question. Okay. Nobody's born in 2011, right? I'm probably safe. Okay. If you're watching this live stream when you're 13, then I suppose if you're 13, then you're not really allowed to engage with the internet, and there's some things which you can't do until you're over 13. Anyway, right, enough stuff about how old people are. Matt question. All we're going to do for this is we've got a polynomial, but unusually we are not going to solve it. We totally could. We're great at solving polynomials. We could solve that polynomial. We could find some solutions. It'll be fine. But we're not going to. We're going to suppose that x satisfies this equation. So x is a number. X is just a number such that, I've written that very small, there we go, such that, it's not much better, such that x cubed is equal to 2x plus 1. Okay, we are given two challenges. First, to prove that x to the 4 is equal to something, and then to prove that x to the 5 is equal to something. Please can I have suggestions in chat for how we might prove that x to the 4 is equal to, well, anything. How can we get from the fact that we've got to this kind of true fact about the number x, I would like a fact about x to the 4. I'm going to switch on chat so that we can play along for this one. And because at the moment at least you fit on the screen at the same time as the question. So help me out. We've got 15 minutes to go to 7 o'clock. Let's see if we can get this. Yeah, anonymous person is going to multiply by x. I love it. It lets me write down a true statement. Right? True statement if I multiply by x. And I guess true statement that also happens to be exactly the thing on the page. Hooray! Yes, love it when that happens. You do an operation, you do a true statement. I enjoyed that so much, I'm going to do it again. I'm going to multiply by x. Now this time, I've multiplied by x, so I've got a true statement, but it's not the thing on the page, because the thing on the page says 2 plus 4x plus x squared, which is not what I've got. I've not got 2 plus 4x plus x squared. While you're letting me know what to do next, I can see, oh, that was great participation there. 5 different people told me what to do. I just waved my arms in anger with so much energy that I met my step goal. So that's nice. The sheer frustration of not having the answer on the page counted as a step. Sub in for x cubed. Yes, carry on. Good stuff. Look at this. Oh, look. Okay. Powered by chat. We know a true fact about x cubed. I'm saying true fact a lot because sometimes in life you know what's going to happen. Maybe there's people watching who are unsurprised by what's happening on the screen right now. Sometimes you can see it all happening in front of you. I will do this, and then I'll get there, and I'll do that, and when I meet them, they will say this, and I will reply with the password. Maybe you know exactly what's going to happen, but sometimes in life, you just have to take one step at a time, and you don't know what the later steps are going to be until you get there, and you see, and you make decisions based on what's happened. So like in this tiny example of that process, I wanted to multiply by x because it would give me an x to the 5. And then a new challenge, I see it's x cubed that I didn't want, but people in the chat keep going, substitute it to get rid of stuff. We can actually keep going, and that's what this question is about. This question is about what happens if you keep going. So you've kind of had the ideas already. The idea there about multiplying and substituting. Okay, chat, we're slightly covering up some data that C5 is equal to the number 1, but that's okay. Chat can just store that. Chat, you can remember that you're the number 1 that's underneath there. Because the question says, for every integer k bigger than or equal to 0, you can uniquely write, so I'm going to put ... on the board, ... x to the k. You can write that as a quadratic. I've gone this way around for the quadratic rather than the other way around. Ah, there we go. Can we get that chat message to line up with? Can we get that 2 down? Just to line up with the C5 statement? Good. Okay, in part 1, you found some numbers. You found that A4 looks like this, which if I write it lowest power of x first is like 0 plus 1 times x plus 2 times x squared. And this one is 2 plus 4 times x plus 1 times x squared, which I've really written out so that we can see it goes 0, 1, 2, like it says on the left, for A4, B4, C4, and 2, 4, 1, like it says for A5, B5, and played tonight by the chat screen. C5 is the number 1. Good, right? I'm really enjoying that interaction. Good. It's the little things. Okay, what are we doing? That's not a question. That's just some facts. To show you that question. Here we go. So this is to show that where we're going to do some algebra. It is possible to show that questions where you explain why something's true, to explain what you would do. And chat's done a great job so far of explaining what they would do. I'm just going to make the observation. Chat is using a normal keyboard and can explain to me what they would do for this question. It's going to be okay. Oh, did I assume gender? Oh no, somebody else assumed gender. Okay, yeah. Maybe I should put them on the list. We're not going to assume pronouns. Keep it at divided by 0. What am I doing? Oh, I'm showing that these things are true. The idea here is that so there's a relationship between a k plus 1 and ck, which relates together the next value of x k plus 1 to the previous things with k's in. Important question, how do we get from xk to xk plus 1 multiplied by x? Oh, I beat you there, sorry. And look, this is going to do exactly the same stuff that it was doing before. Only now we're a little bit more general, but we still want to do the same thing of replacing this x cubed with the only thing we know about x cubed, that it's equal to 2x plus 1. Sorry for the brackets there. 2x plus 1, which I've written tiny underneath. If you do that and then compare, then you get, on the one hand, this thing is equal to a k plus 1 plus b k plus 1x plus c k plus 1 x squared. But on the other hand, it's equal to this expression we just found. And if you compare, then you get those things out. Okay, get those relationships. There's a complicated 2 times ck from this term. Side note, which I think I put in the extensions. Maybe? No, okay. Side note, this doesn't quite work really, but never mind. Oh, right, okay. There you go. Put up the pronouns. 50-50. No, not quite. Good, okay. Okay, part 3, we're going to define a new thing, which is dk to be ak plus ck minus bk. And we're going to show that something is true. At this stage, I would use the results that we had before. So, sorry chat, I'm going to put you, get a little bit more space, I'm going to put you there so that I can say, okay, we're asked to show something about dk. We're asked to show that dk plus 1. So I'm going to write out a statement about dk plus 1, which is of course a k plus 1 plus ck plus 1 minus bk plus 1. And say that this is, well, I have all these facts about a k plus 1, don't I? I know that AK plus 1 is CK. I know that CK plus 1 is VK. And I know that BK plus 1 is the complicated mess of AK plus 2CK. So what's that going to be? This looks pretty reassuring. There's this BK here. Ooh, have I messed up? I'm not sure. Oh yes, I've got this BK which is negative of this term. Let's do the matching. I'm going to try and draw BK which is minus of this term. I've got AK which is minus of this term, so it's matching up. And then I was a bit worried about the CKs, but just in time, this minus 2CK came through to pair everything together. So that this really is minus DK. Lovely. Okay, last bit of two. So at the very last moment, I did a little bit of compare coefficients. On the one hand, this thing is also AK plus 1 plus BK plus 1 x plus CK plus 1 x squared. But I've got this new expression for it now, which is a bit messy on the right hand side, but if you rearrange it and match things up, then you'll see the relationships in the question at the top of the page there to match things together. Okay. Right, okay, so dk plus 1 is negative dk, so where I think I've got to. And hence always means using the previous part. It's a little bit Old English, sort of, hence. We had this thing, hence I shall go. Anyway, never mind. I quite like it as a word. It always means, as a clue to you, that it uses the previous part. Here, look, we've just said that dk plus 1 is switches. It's got these minus signs in. So it's my old nemesis, minus signs. For the third time today, we're going to have a big stack of minus ones. Here they are. Each one is negative, kind of previous term in this sequence. I'm thinking about these as a sequence now. Dk plus 1 with that subscript k plus 1 to mean it's the previous term of the sequence but with a minus sign. And also, I suppose we know that we know some values of these things. D4, for example, we know that that's A4 plus C4 minus B4, which is 0 plus 2 minus 1, which is 1. So after that, they're going to keep going backwards and forwards with minus signs. 4 is one of the examples we worked out at the top. So then they're going to keep bouncing backwards and forwards with minus signs. So we end up with this rather nice relationship there that that thing on the left is the definition of dk, and it's minus 1 to the power of n. They keep bouncing backwards and forwards with those minus signs. The jump by dk plus 1. I don't think that's a jump. This is true for all k, including the next value of k. So is that a jump, or is that me saying, okay, this is true for all k, so it's also true for the next value? It might have been nicer for me to use a different letter of the alphabet, maybe not k, but for any number you like, D37 is equal to this definition with 37s down here, and D38 is this thing. Well, you're going to put 38 down there. What does dk even represent? Yeah, good question. Good question. Extension question on the worksheet, if you would like a bonus bit of question, is to work out what's going on with this question and what the value of dk actually means. Because it's pretty random, right? This combination of things that just gives you a minus 1 lots of times. Weird. Okay. Finally, there is a surprise guest feature from the Fibonacci numbers in this question. Here they are. We're going to let FK be AC plus, my goodness, we're going to let FK be AK plus CK. Oh no, oh my goodness, what is this? What is this last part saying? It's going to be okay. It's saying it's going to be okay. And I think I'm running out of time, but you can prove that last thing about those Fibonacci numbers, because each one is the sum of the previous two. You can prove that by using the result we just had, this thing about the sums of the A's and C's. So on the left, I'm going to have a couple of B values. On the right, I'll have something to do with B, K plus 2. But I know loads of facts about all of those things that will help me relate B, K plus 2 back down to things involving K plus 1 on the subscript, and maybe also things involving K on the subscript. I think I can just piece together all the relationships. Alternatively, I know things about A's and C's, so maybe I should just replace all this with A's and C's. I mean, a k plus 1 is just equal to ck up here. So you've got choices about how you plug things together and what you put in. Okay, if you want to see all of that algebra for working out the f's in slow motion, more or less, then I recommend the solutions doc. But I've hit 7 o'clock, which means it's time to stop the episode, I think. Any last questions? We're going to be back next week, of course. And if I haven't answered your question, I'm really sorry I missed your questions. Then you can email us. There's an email address in the YouTube link. Or if you're on the MAT page, then there's a contact us link at the bottom that also goes to me. Or see you next week. Right, anything else going on in chat? No, I'll give you a moment. But we'll see. People say thank you, which is nice. Good. Right. Okay. Back in the driving seat for MAT Livestream. It's been a little while since I've had this set up with a chat on and off, and let's switch it back on again. There we go. No, people just say thank you. Okay. Good. Right. Cool. If you have any more questions after the show, do get in touch by the contact routes. Either way, I'll see you next week for some algebra with polynomials. Time for algebra, very connected ideas there. So we'll be back in 166 hours for another episode of the Oxford MAT Livestream. Quick maths there, right? Take care, everyone. Have a good evening. Bye.